Welcome to part 2 of the series Building Flappy Bird in Unity3d. If you haven't already watched the previous video, go back and watch that first so you can follow along. Now that we're back in the editor, we need to add some code to make our fish controllable by the player. So the first thing we want to do is create a new folder for our code. We want to keep everything separated and kind of clean so that way when we're going back later, we know where our code is, where our art is. We don't have to search around for stuff. So to do that, I just clicked in the assets folder and click over here in this area, right click and hit create folder, and I'm going to give it a name code. If you accidentally hit enter and named it new folder, it's okay. You can just hit F2 to rename it and just type in a new name here. Now I want you to go into the code folder. You can just double click on the code folder. Then right click and hit create C# script. We're going to name this script fish. Alright, our fish script has been created. Now, if you're in Windows like I am, I want you to go to the Edit menu and then to Preferences, and then select External Tools, and for your external script editor, select Visual Studio 2015. If that's not an option for you, don't worry about it. You can still work along in MonoDevelop. Visual Studio just gives a little bit nicer environment for writing our code. And if you're on a Mac, again, totally fine to work in MonoDevelop. So don't worry about it if you can't do that. Then hit close. Now let's open up our fish file and look at the code that's been auto-generated for us. To do that, just double click on the fish and you'll see it's opening up a Visual Studio instance. If you're in MonoDevelop, it's opening up a MonoDevelop instance. But the code will look exactly the same. Okay, here you can see the code editor with the fish class that it created for us. So a couple of important things to notice in here. The first is just the name of our class. So because we named it fish, we're going to have public class fish. So anytime we're interacting with this code, it's going to be fish something. The other important part is that its base class is a mono behavior. What that does is it allows it to become a component of our game object, just like the camera component when we looked at that earlier. Having mono behavior as its base class really just means that we get a couple of things kind of for free. We get some methods where we can hook in and add our own code throughout the game. The first one here you can see is start. This gets called when our game object is created or the game starts playing or a level loads. And then we have update. Update gets called once per frame. Most games run somewhere between 30 and 90 frames a second, so you can imagine this gets called 30 to 90 times per second for each object that this component is on. Now to make this a little easier, I'm going to turn on line numbers in Visual Studio, and I just want to show you how to do that in case you're in here. So just go to Tools, Options, up here type in line numbers, or line num, select it right there, and just change that to a check mark. There we go. Now we have line numbers alongside. You should have these in MonoDevelop as well. So what I want to do is just take lines 6 through 9, select them all, and hit delete. Next, we're going to go into the update method and add a little bit of code. Now, tab in and add the following code. Okay, so what we're doing here is creating a Boolean variable, and we're setting the variable's value to the result of input.getButton. Input.getButton is the getButton method on input tells us whether or not a button has been pressed since the last time update was called. So this gets called 30 times a second. It'll tell us every 30th of a second whether or not the button was pressed and released. And the button that we want to get the status for is Fire 1. This is a default button in Unity. It's bound to things like space, the left control button, your left mouse click. If you have an Xbox controller hooked up, it'd be the A button on there. The next line of code we want is to check whether or not that value was true. And if that value was true, we're going to do something afterwards. So to do that, we just add if, and then some parentheses. Pressed fire button. And then we'll add a new line. Some braces. And inside these braces, we're going to type a little more. We're going to type rigid body 2D, capital R, rigid body equals get component, and then less than sign and rigid body 2D. And then after that, we need parentheses and a semicolon. So what this does is get the rigid body from our object. So let me go back to the fish. So if I look at the fish, we have this rigid body on here. This code is going to get that rigid body so that we can interact with it. Now back to our code. We want to do something with this rigid body. So the first thing we want to do is stop it. We'll do that like this. Call rigid body with the lowercase r dot velocity equals vector3.0. So what that does is set our velocity, the rigid body controls that, to 0 in every direction. So if you're looking at our position where we have X, Y, and Z, it could be moving along any of those axes, and we want to stop it across all of them. So setting its velocity to 0 essentially stops it in its tracks. The next thing we want to do is add a little bit of force in the upward direction. To do that, I'll type rigid body dot add force, and we want to do vector3 dot up, and we want to multiply that by 1000. So vector3 dot up is the same as a vector, or it's a direction that's pointing 0 in the x-axis, positive 1 in the y-axis, and 0 on the z-axis. And then we're multiplying that by 1000. So we're adding a force of 0, positive 1000, and 0. Now I'm going to save the file. Just Control S. See, the little star went away if you're in Visual Studio. Now let's go back into the editor and add this code to our fish. So to do that, we just need to make sure our fish is selected. Then go over to Add Component, and I'm just going to type fish. And you'll see it's a little C# logo there. Hit that, and now we have a fish component on our fish. So if I hit play, I should be able to stop the fish from falling. Click, oh, there he goes, he flies way up. Should fall back down, and hit it again, he flies back up again. Now, as you can tell, that value is a little bit too high. We're giving too much force. It's more than we want. So we're going to make it adjustable so we don't have to keep going into our code and changing it over and over. To do that, we're going to add a property that will show up in the inspector. We're going to name that upward force multiplier. So right here on line 6, I'm going to add private float and then an underscore upward force multiplier, and I'm going to set it to 100 and put an F there because it's a floating point. On line 5 though, I'm going to insert a line, so I'll add another line, the new line 6. I'm going to put a square bracket and type serialize field. What that does is make it so that this variable is available in the inspector. So if I click back to the inspector, so here you can see after hitting play and stopping, we see the upward force multiplier with the fish selected down in the fish script area. So let's go back to the code and actually use that value. So to do that, we're just going to replace this 1000 with the upward force multiplier. Now I could just type that, but I'm being lazy, so I will select it, copy it, and then select the 1000. You just double click to select a whole area and paste. There we go. Now we're multiplying up times our upward force multiplier, which is currently 100, but we can set it in the editor now. So I'll save that. We'll hit play again, and we should be able to adjust our fish's multiplier now. So you can see I'm clicking, and I have to click really, really, really fast. I'm going to stop, and I'm going to just turn that number up. Let's try something a little bit bigger, maybe 150. Hit play, see how that feels. Well, it still feels a little bit low, so I'm going to stop again, and I'll bump that up to 200. Now if I click, that feels about right. We can always go in and adjust it later. So go ahead and pick a number that you feel good with. 200 feels about right to me. If you want a little higher or lower, that's totally fine. Now, one thing to note though, don't make these changes while you're playing. So if I'm playing and I change this number, say I change it from 200 to, let's make it something really big, 300,000. Right, and I click play again to stop, you'll see that number reverted. And it does that for a reason, because you don't want your values getting saved when they're getting changed by other things in the game. So you always need to make sure that you're not playing when you're modifying values that you want to keep around. And it's totally fine to modify them while you're playing if you just don't expect them to be saved. Alright, in the next video we will cover adding a little bit of seaweed and some collision detection.